Polarization, that is a transverse nature of light. Light is an electromagnetic wave in which electric and magnetic field vector vibrates perpendicular to each other and also perpendicular to the propagation of light. So light is transverse by nature. Let's consider this is a string when we set up a vibration in this string will look like this. This is x-axis and it is y-axis. Particle in string vibrates perpendicular to the wave motion. The equation for such wave is written as y x comma t equals to a sin kx minus omega t, where a is the amplitude of the wave, omega equal to 2 pi m angular frequency of the wave, and lambda is 2 pi by k wavelength. As the displacement of particle is along y-axis and wave propagation is along x direction, so the wave is transverse. It is called y polarized wave because in this case the particle vibration is along y direction, and this shows a z polarized wave because vibration is along z direction and movement is along x direction. Now equation for this wave will be z x comma t equal to a sin kx minus omega t. Since every point of a string moves on a straight line, the wave is also called linearly polarized wave. Also the state always remains confined to the xy plane, so the wave is also referred as plane polarized. In ordinary light, that is light direct from sun or lamp, the vibration of electric field is perpendicular to the direction of wave propagation. The electric field changes its direction rapidly and randomly in the vibration plane. This type of light is called unpolarized light. Here this is shown. This is the direction of wave, and if we draw a perpendicular like this, and then the particle vibrate in all direction, like similar like this, and so, and the direction of vibration is also changing with time. So such type of wave is called unpolarized. Representation of a unpolarized light. Unpolarized light is diagrammatically represented like this. This line shows the vibration in the plane parallel to the plane of paper, like it is vibrating like this, and this point shows the vibration perpendicular to the plane of the paper. Vibration in the plane perpendicular to the plane of the paper. For example, this is this is in the plane of the paper, and this is perpendicular to the plane of the paper. Polarization: when ordinary light is passed through a tourmaline crystal or crystallographic axis perpendicular to the direction of wave propagation, the vibration of electric field in the transmitted wave are confined to only one direction, that is parallel to the crystallographic axis. Thus, the transmitted light is linearly polarized or plane polarized, and the phenomenon is called polarization. Here is the source of light, which the light from this source is unpolarized, and this is shown by this diagram. Now if this light is passed through a crystal, tourmaline crystal, then after passing through this tourmaline crystal, the vibration of light perpendicular to plane is removed, and only vibration in the plane of the paper remains. So this type of light is plane polarized light. And this is the crystallographic axis, pass axis. This is also called pass axis. The plane containing the crystallographic axis in which vibration occurs is called plane of vibration, and the plane perpendicular to the plane of vibration is called plane of polarization. That is, this is the plane of vibration because particle is vibrating in this plane like this, plane of polarization, and this is the plane of vibration. Now Polaroids. It is a device used to produce plain polarized light. It contains a long chain of molecules aligned in particular direction. The vibration along the alignment of molecules is observed and perpendicular to the alignment of molecules is passed. In this light transmitted through the Polaroid is plane polarized. The direction perpendicular to the direction of the alignment of the molecules of the Polaroid is known as uh, Polaroid axis or the polarizing direction of the Polaroid. Here a ordinary unpolarized light is passing through this Polaroid, and this is the pass axis of Polaroid, and after passing through this the light becomes plane polarized. That is, light start to vibrate in this only in this plane, and so this is called plane polarized of light. And the alignment of molecules becomes like this. Experimental verification of transverse nature of light. Here a polarizer is used, and a light from source is passed through this polarizer. When it passes through the polarizer, the light becomes plane polarized. Only vibration of light is in this direction, and when it passes through this, because the axis is now perpendicular to the plane, this vibration. So after passing through this, there is no light is obtained, and this is called analyzer. This plate is called polarizer, and this plate is called analyzer. Mallo's law. According to this law, the intensity of completely plane polarized light transmitted through the analyzer varies as the square of the cosine of the angle between the plane of transmission of the analyzer and the plane of polarizer. That is, I proportional to cos square theta, where I, this implies equals to I naught cos square theta, where I is the intensity of light transmitted from analyzer, and I naught is the intensity of polarized light, and theta is the angle between plane of transmission of polarizer and analyzer. So this is the situation shown when we pass through the light, it becomes, this is the polarizer, and light is plane polarized. When pass through this, light becomes no light is obtained. So this is called analyzer. Here it is shown. This is the plane of polarizer, that is plane parallel to the plane of paper, and this is the plane of transmission of analyzer, and this is shown here like this. And this is represented in xy plane of transmission of polarizer, and xz plane represent the plane of transmission of analyzer. Now, polarization of light by scattering. When light is incident on a small particle of dust, air molecule etc. having a smaller size as compared to the wavelength of light, it is observed by the electrons of the atoms of these particles and re-irradiated in all directions. The phenomenon is known as scattering. The light scattered in a direction perpendicular to the direction of incident light is plane polarized. Here the source is shown, sun, and dash dash dash, and unpolarized light is passing, and it strikes a molecule or dust particle and scattered in this direction. In this direction, plane polarized light is scattered light is plane polarized light. There is the observers who sees this light. The electrons in the molecule vibrates along the direction of the field and thus behaves like a oscillating dipole and emit radiation in all directions except in its own line of vibration. Polarization by reflection. When natural light obliquely incident on a glass slab, it is partly reflected and partly refracted. The reflected and refracted light are partly polarized. At a particular angle of incidence, the reflected light is completely plane polarized. This angle is called polarizing angle or Brewster's angle. Brewster experimentally found that in this case, the reflected light and the refracted light is perpendicular to each other. Here a unclosed light is incident uh, on a reflecting plane. This is the angle of incidence and this is the angle of refraction. And the reflected light is partly polarized and transmitted light or refracted light is partly polarized. Brewster's law. The refractive index of the refracting medium is numerically equal to the tangent of polarizing angle. Proof. Here this is a light which is incident on at point O and refracted along OB and refracted along OC, and this angle is 90 degree, and this is the angle of incidence I, and this is the angle of refraction R, and this is called angle of polarization where this becomes 90 degree. If the angle between refracted and reflected and refracted light is 90 degree, then angle of incidence is called Brewster's angle. When I equal IP, the polarizing angle, according to Brewster experiment, angle BOC equals to 90 degree. So that angle R plus angle BOC plus R dash equal to 180 degree. And angle R plus 90 plus R dash, 90 R plus 90 dash plus R dash 180 degree. This gives R plus R dash equals to 90. This implies IP plus R dash equals to 90. Since IP equals to R, angle of incidence is equal to angle of reflection, law of reflection. And R dash equals to 90 minus IP, question 1. If n be the refractive index of the refracting medium, then from Snell's law n equals to sin I by sin R dash, or equals to sin IP by sin R dash. Equation 2, using 1 and 2, we have n equal to sin IP by sin 90 minus IP, or equals to sin IP by cos IP equals to tan IP. Hence n equals to tan IP. This is the Brewster's law.